Hello everyone, welcome to the tutorial of NPTEL course Programming Data Structures and Algorithm in Python by Professor Madhavan Mukund. I am a teaching assistant Jivesh Dikshit. Uh, basically, for the tutorial of week 0, we will we will look at the basics of Python. The inventor of Python, Guido van Rossum, he mentioned about the need of a need of the development of a language like Python by saying Python is an experiment in how much freedom programmers need. Too much freedom and nobody can read another's code. Too little and expressiveness is endangered. So as we'll move on in this course, we'll see how the freedom and expressiveness is optimized during the development of the Python. So Python was invented in early 1990s by Guido van Rossum. So since starting, it's a scripting language. By saying scripting language basically are they are not compiled language, whereas they are interpreted languages. So in interpreted languages, basically the source code or the code written by developers is read first read in the background for the instructions, and if the syntax of the instructions is correct, then they are converted to a intermediate a language called bytecode, and then the bytecode is further interpreted by Python virtual machine, or that is called Python interpreter. And in case there is no error, machine Python interpreter converts to a machine executable code. And if it's not error free, then it the program halts with an error message. Whereas in compiled languages, the source code is converted to a low level machine language by the compiler, and if the errors are if the errors are available, then it lists all the errors at once, and if errors are not available, then the program is executed and output file is produced. Python is also object oriented languages and also supports functional programming, that it makes its syntax easy to read and write. That's why it's a good choice for beginners. For example, unlike C and Fortran, variable type declaration is not required in Python. So we'll see it in coming slides. First of all, we'll look for the download and installation. So basically, Python is managed by Python Software Foundation, and on their website, which is this, we can find all the download for all major operating systems such as Linux, Windows, and Mac OS. Installation procedure for these major operating systems is available online on many websites. One of them I have mentioned here. We can follow the steps and steps for installation, and we can install it comfortably on any of the operating systems mentioned above. So we'll just look for these links. So we can see here, basically this gives the information of installation of Python on Windows. It clearly mentions the steps here, and then it gives the installation procedure for Mac OS and Linux as well. Now for beginners, on the website python.org, this beginner guide is also presented. So in this beginner's guide, we can we can have information about the persons who are new to programming, or who have never programmed before. So like here we can see that the tutorials for the beginners, or non-programmers, and below that there are tutorials who has a previous programming experiences. Similarly, a full documentation is also available on the website, and this full documentation is available for all the past versions and the version that is in development. So here we can find the documentation for all the versions of Python. Like we can see here, it's for Python 2.7, 3.5, and up to 3.12, which is yet to be yet to be released as a stable version. So full-fledged tutorials are available here, and uh, other than that, we can see that the supported modules for Python, the information about the installation procedure and all is mentioned here. So the documentation of Python is quite extensive, and it is very much helpful for the beginners as well as to the person who has some programming uh, experience. Now, to if we now to start with it, or to begin with Python, if we want to start writing our script, we would require a code editor or text editor or integrated development environment. So basically, integrated development environment are different from text editors, because they also have ability to debug and run the code, whereas text editors are used to simply write the script. So here some of the IDEs or text editors are presented. So like idle is a IDE. So in idle we can write our script, we can run Python interactively, or uh, we can debug and run our code. Other than that, we have Sublime. Sublime is kind of a text editor or code editor. We have Notepad++, Jupyter Notebook. Jupyter Notebook essentially runs on the internet browser. So it's quite handy. Unlike the text editors, in it we can run our code line by line or cell by cell. So in cell we can write our code, and we can check by running it whether it's producing a desired output or it's producing some error, so we can correct it in between. So it is very helpful in long codes. Other than that, we have Spider. Spider is meant for scientists, data scientists, and engineers. It has very helpful uh, GUI uh, for scientific purposes. We can choose any IDE or code editor depending upon our comfort, but it is always wise to choose an IDE or text editor that has some features, like it should be multi-windowed, it should have a syntax highlighting feature, it should have a auto completion feature, and it should also support smart indentation. So other than writing scripts, we can also run Python interactively using command line interface in operating system. So now we'll see how to play with Python in interactive mode. So Python on Linux terminal, it can be called by writing Python 2 or Python 3, depending upon what version we need to call, if more than one versions are installed. and then after calling it prompts with this symbol here. So here we can see that I have called Python 3 in my computer. So it opens Python version 3.8, and when after opening Python, it basically prompts with this symbol. Now we can see that if we try to do some numeric operations, so like here we have written 4 plus 7. So when we press enter, we get the output as 11. So it has done addition for us. Now, if we want to do a numeric operation and we want to store it in a variable, so we can put it like this. So here I have stored the value of 10 into 12 in a variable A. Similarly, I have stored a value 18 in a variable B. Now, if we try to, other than numeric operations, if we try to do some logical operations, or we, like here, we try to check a conditional equal to, so we are checking whether A is equal to B or A is not equal to B. So uh, for that, uh, for conditional equal to, we will use double equal to sign, whereas for assignment we will use single equal to sign. So A equal to B, it produces false because the value of A is 10 into 12, that is 120. Value of B is 18, so they are not equal. So when they are not equal, so the condition is false, hence false is returned. So if A were equal to B, then A equal to B would have produced true because the condition would have been true. Now, if we I now I will choose another simple numeric operation involving multiplication, subtraction, division, etc., and I will store it in another variable C. Now, if we try to print the output of C, we get it 0 0.0. So this point here is a floating point. It separates the whole number. It separates the whole number uh, with the fractional part of the number. So here we can see that A does not have any floating point, B does not have any floating point. So A and B in Python, they will be put under int or integer class, whereas C has a floating point, so it will be put under class float. So as we have already discussed, in Python we need not to declare the variable type. A variable is declared in Python automatically after the assignment of the variable. So we can see when we check the type of A, B, and C, type of A is int, which was expected. Type of B is also int, whereas type of C is a float. Now, if we want to, after doing our operations or writing functions, uh, or uh, uh, or collecting output from the function and writing it to the file, if we want to exit the Python interpreter, we simply need to type exit and exit and parenthesis and press enter. So after pressing enter, the processes will be closed, and we will get out of the Python interpreter. Or we can also press Control plus D. So this will also close all the background processes and we will exit the interpreter. So you can try some of the operations to get the Python flavor in interactive mode. Now, if we want to execute a script file that we have written in a text editor or in any IDE using Python interpreter, then what we need to do is we'll write a program in .py format. So it's very important that it should be written in .py format, and so that it could be called in Python interpreter. So like let's assume I have written a file that has a name file name.py. So I will be running it by calling Python filename.py, and I'll press enter to get the appropriate output. Now to make the, if we want to make the file automatically executable so that we need not to call it with Python, we can add an appropriate path to Python interpreter as the first line of the code. So basically here what we need to do is, we will, in the first line, we will put hash, then an exclamation mark, and without any white spaces in between, we will give the location of the interpreter, Python interpreter. So like in my case, my Python interpreter is installed in user bin Python. Uh, so basically, it's in general it's installed in here. But if in your case it's installed at some place else, we can check it by typing which Python. So it will give us the location of the interpreter, and we can put that location there. Then after that, we'll run the command in terminal, that is change mode all plus executable and file name .py. Now, as our file has become automatically executable, we'll simply run it by typing uh, so here it's a mistake. So our file name was fact.py. So we'll run it by typing dot slash fact.py. So this is how all the executable file in Linux are run. So when we will put will put press enter, after that all file will be executed. So we'll try to look it with an example. So let us say I have written two functions here. So if I look at my first function, so in this function, I have written this first line as hash exclamation and path of my Python interpreter, where and we have defined a function that is f underscore to underscore c. This function basically converts the temperature in degree centigrade into degree Fahrenheit into the temperature in degree centigrade. This line is basically commented line. This line is not interpreted by the Python, and we will see in subsequent slide why it is not interpreted in the Python. Then in next line, after this colon, when we want a line to be interpreted inside the block of the function, we will give an indentation, and after indentation, we will be writing our lines that we want to be executable. So here we have written our formula for converting temperature in degree centigrade to temperature in degree Fahrenheit to temperature in degree centigrade, and we return the value of C. So now here our function ends. So after that, we will not, our next line will not be indented, because our function or block ends here. So this is our block. So when our block ends, we will come out of the indentation, so that Python will know that we are not inside the block anymore. So now we want the value of temperature in degree Fahrenheit from the user using this inbuilt function in Python called input. So input allows user to input the desired value. It prompts user to input the desired value, and this value, when you input, is basically taken as a string. So string is not a numeric data type. So if we want to convert it to a numeric data type, we have seen earlier that Python had numeric data type classes as int and float, and we'll talk about them in upcoming slides as well. So basically, we'll convert our temperature in degree centigrade into float, because temperature can have a floating point in between. So as we know, the temperature of human body is 36.7 degrees centigrade or so. So it's a floating point number. So for that, we can get a required precision while conversion. We will use the float. We will use our data type as float. So we have input our temperature in degree Fahrenheit as float, and then we want computer to print the output on the screen as the temperature in degree centigrade and the output of the function which returns the temperature in degree centigrade. So it print is also an inbuilt function which prints the output on the screen so that user can have a look at it. Now we'll try to run this function. So we are inside the same directory as this function. So we'll try to run it. So let us say we try to run function is f underscore 2 dot py. So when we run this, it prompts me uh, to enter the temperature in degree Fahrenheit. So we already know that temperature minus 40 degree Fahrenheit is same as temperature minus 40 degree centigrade, or the temperature of human body in degree Fahrenheit is around 98 degree Fahrenheit, which is converted to 36.7 degree centigrade. So this is how. And now if we want to make this function executable, what we need to do is we would uh, simply change the permission so that the file becomes executable by typing chmod a plus x. A stands for all, and x plus x stands for executable, and we'll give the file name, and then we can run the file by simply typing this. Now it prompts for temperature in degree centigrade without typing the python 3 f underscore 2 underscore c. It simply we can simply type dot slash and file name, which is a standard way of running a executable file in Python, and we are prompted and the function is executed. Then we can get the desired output by simply running this. Now we have another file in which the first line is not in first line we do not give the path of the interpreter. So if we try to check whether we can make this executable or not, we'll simply try to do is chmod, then c underscore 2 underscore chmod, sorry, all plus executable c underscore 2 dot py. Then we'll try to run it. So basically, uh, okay, this file has given a different kind of error, as this file was created in Python, is created in Windows, and we are trying to call it in Linux system. So it's that kind of error. So we'll correct that error by opening this file in Linux system by using vi editor, and then we will simply set the file format to be Unix, and then we'll save the file. Now if we try to change the permissions and then we try to run the file, we get an error because the path of the interpreter is not defined here. So it does not know that with what interpreter or compiler it should be run. So but we can run this file using writing simply python c underscore 2 dot py. Okay, so I have python 3. So python 3, then it prompts for temperature in degree centigrade. As we have already seen, temperature minus 40 degree centigrade is same as minus 40 degree Fahrenheit, or temperature 36.67 is equivalent to around 98 degree Fahrenheit. So this is how we write our functions or scripts in a text editor, and we can run that using a Python interpreter. Now, uh, while writing Python codes, it's very important to respect the syntax of the language. So basically, if we do not if we take the freedom to not write the Python syntax properly, we either get the unexpected outcome or we can get an error. So it's very important to carefully write the syntax of the Python, especially in long codes where they may take long time to run, and any as it is run line by line. So if there is a error at near end or so, it could really be troublesome. However, the syntax error are instantaneously thrown. So, but still, we need to be very careful while writing the syntax for any language, and hence in case of Python as well. So basically, block structure in Python is indicated by indentation, as we have already seen while we defined the function. So after defining the function, we wanted the lines which we need to be within the function. So we have given an indentation so that the Python knows it is a part of that function definition alone. And when we wanted to get out of the function definition, we simply remove the indentation and start writing our code. So that example we have just seen. So as we have discussed, improper indentation, it can lead to an error or unintended result or unexpected results. So then assignment to a variable creates the variable, and we need not to declare the variable type at all. That example also we have already seen. uh, Variable is assigned by equal to operator. So we have seen in one of our examples where we simply assigned a to be 12 into 10, and then this assignment was done by equal to operator. Then we again assigned b is equal to 18, and we tried to check the comparison between a and b, or with comparison equal to operator, we tried to check whether a is equal to b or not. So double equal to represents the comparison operator. So all the standard operators are supported in Python. So like addition, subtraction, multiplication, division, floor division, modulus, power, etc. So now more more Python operators can be found at this particular website. So if we follow this particular link, we can see many type of operators that are available in Python, like arithmetic operator, assignment operator, comparison operators, etc. So we have already seen arithmetic operators, we have seen one of the assignment operator, we have seen one of the comparison operators. So there are many more like that. So those are supported in Python. So we can get the flavor of those operators at one place. It could really be handy when you are new to Python and start writing your scripts. Now, as we have already seen that if we want to get our output printed on the screen, we can use the inbuilt print statement inside the Python. Now, basic data types in Python. So we have already seen integer, float. So basically, integer, it is a positive or negative whole number without any floating point in between. So it can take practically unlimited length. Numeric operation between two or more integers can lead to a non-integer output. So this thing we can see that if we have two integers, let us say I am calling my Python here, and I want to do an operation between a division operation between two integers, that is 3 and 2. We are getting an output that has a floating point in between. So basically we are getting an output as a float. Now, numeric operation of an integer with a non-integer will always lead to a non-integer output. So, whether we do an addition, subtraction, multiplication, division, etc., we are always going to get a uh, non-integer or float kind of output. So let's say I want to, but let's check one thing. If I want to do a floor division with an integer and a float, so what we are going to get? Even in floor division, basically in floor division, what it does, it returns the nearest integer leaving the fractional part. So basically it returns kind of greatest integer, it behaves kind of greatest integer function. So it returns the nearest integer lower than the value for positive and greater than the value for negative function. So here 3, when we divide 3 using floor division, we get the value 1.0. Let's try it between two integers. So let us say we do 3 by 2. We are getting an output as a integer. So any operation between integer and non-integer is going to produce a non-integer output. Now similarly, another class we have seen, that is a float. It represents the real number with a decimal point that separates the whole number and a fractional part. That so basically it is they are separated by a floating point in between, hence called floating point numbers. So operation between two or more floats will always be a float. Operation between integer and float will always be a float, as we have already seen. And there is a built-in class for integer and float. Both are called int or float respectively. Another important data type is complex. So basically numeric data type, this numeric data type basically takes a form real plus imaginary multiplied by j, where j is under root minus 1. So basically in Python, the complex number is defined by the class complex, and then the syntax is like we'll write complex, then in parenthesis we'll use the single quote or double quote, and inside that single quote or double quote we'll write the real part plus imaginary part and j. So we'll just have a look at that, how to define a complex. So let's say I'm going to store this complex variable uh, in A. So let us say 3 plus 4j. So we can see the type of A to be complex because it has been called using a class complex. Now we need to be very careful while defining the complex numbers, because if we use any white space or any space or tab around this plus, so it is going to result in a value error, because the string is not provided to the Python as expected. So there should be no white spaces around this plus sign. So we can, let us say we change this location of white space, or if any kind of operations with white spaces around the plus sign will result in an error. So we need to be very careful. There should be no white space between around the plus sign, so that our complex number is defined. Now, as we have talked about the white spaces are meaningful in Python. Basically, we have seen in case of indentation, white spaces as an indentation meant for the definition of blocks in Python, and the placement of new lines as well. So when our instruction line ends, we can go to the new line. So rest of the white space will have a meaning that we have moved to a new line. Now A backslash can also be used when we need to go to a new line prematurely. By saying prematurely, I simply mean that even if our line is not completed, we can move to a new line. So, for example, let us say I want to do an operation 3 plus 5 multiplied by 12 minus 16, 15, and a division operator, and I want to move to a new line, and I am assuming that this line is prematurely ended, this has not completed, I want to move to a new line. Then if I press enter, I will get an error because the syntax is invalid. The Python does not know we want to move to a new line prematurely. So for that, what we do, we would put a backslash at the end, and it would allow us to move to a new line, and we'll do the division by 2 and press enter. Our output is generated without any error. So we need to be very careful while using the syntax in Python. uh, White spaces and the operators, they are very much meaningful. So as we have already discussed in the starting, there should be a balance between freedom and expressiveness. So as we have seen till the point that Python is very expressive, but we need to respect the syntax of the Python. Now, as we have already seen and discussed that no braces to mark the blocks of the code. So like in C, we need to mark the braces, but in Python, we need not to mark the braces. Consistent use of indentation will actually define the blocks in Python. Other important point is colons basically start of a new block in many constructs, such as we have seen in function definitions. So if we look at our code here, so after defining a function, we have put a colon, and then we have started a indentation, and we have completed our block, and then we have moved out our block by removing the indentation. So basically, whether it's a functional construct or there are loops, so we'll see in coming lectures that even the loop construct also start with the colon marks. Now, comment in Python are very, very important because clean and meaningful comments improve the readability of the code. And anywhere in the line, if hash appears, anything written after the hash is not interpreted by the Python at all. So that thing can be used as a comment, which increases the readability of the code. So we'll look at a simple example. In this example, we have not given any comment, so we do not know what this function does at all. Whereas if we look at this function where we have used a comment line, this comment line actually makes it clear in our mind that this function basically converts the input in degree Fahrenheit to an output in degree centigrade. We could have written it much more clearly. So it's totally up to us how well we write those comments to make to increase the expressiveness, or to increase the expressiveness or readability of our code to others. Now, naming conventions and rules in Python. So a Python is a string of characters and numbers. The assignment operator, it is used to assign values to a variable in Python. So this thing we have already discussed. Variable is basically analogous to a container to store the data in a computer memory, whereas variable name of the variable specifies the location of the particular value in the memory. So basically, variable stores the value of the value assigned to it, whereas variable name tells us what is the value associated with that particular variable name. Variable names in Python are case sensitive. They are case sensitive, and uh, uh, they must not start with a number. So I have given here some examples of the variable name that we can use. We can use underscore safely in our variable name. It does not create any problem, and we can use it anywhere we like. but we need to be very careful that this variable name should not okay, so variable names are basically case sensitive, and they should not start with a number. So we must be very careful that our variable name does not start with number. It can start with a special character like underscore, or it can start with a alphabet, but it should not start with a number. We need to be careful that if we see this variable name and this variable name, they are used separately, because we see that if we do not consider the case sensitiveness of the variable name, they both look same. But as the name written here and name written here, one is in lower case, other is in upper case, hence they will be treated separately in Python. However, there are some names which are reserved in Python as their function names, and we should not be use them at all. For example, we have and, assert, break, import, in, lambda, not, etc. So these should not be used at all as our variable names. Now, uh, we'll move to sequences in Python. So basically, there are various sequences in Python, such as tuple, list, range, etc. So Pythons are useful. These sequences are useful for iterations. Um, Let us say, first we one by one we'll talk about the tuple, list, range, and string. So they in Python basically are defined in the following manner. So let us say I want to define a tuple. I want to define a tuple A. So if I want to define an empty tuple, we can simply put an empty parenthesis, and we can check that this is defined as an empty tuple. Uh, if we want to, but for the definition of tuple, a parenthesis is not necessary. For example, if I want to define a tuple, then we can define a tuple by saying 3 comma, and so we'll see that this is a tuple. Or we can define it without parenthesis, and if we try to get the output which is same as the tuple definition that we have used earlier, and the type of this A will also be a tuple. Or if we want to define a tuple with a large sequence, we can do that by simply saying, and the other more important thing is it can take a mixed values. So these 2, 3, and 8 are integers values, and then I want to define a string value in between, and then I want to give a float value, then I want to give a complex value. So the tuple, this can be defined by all those things at a time, and if we see that it returns us integers, uh, string, float, and complex numbers. So tuple can take mixed data types, but one important thing with tuples is that they are immutable. So once we define a tuple and we store it in a variable, we cannot change it. So if we want to change it, we will have to store it in a new variable. We cannot change it in the same variable. Now tuples, as we have seen, the tuple sequence can take a mixed element types. So basically these are the operations, these are the common operations, common sequence operations. So these operations are for the immutable type of sequences. So let us say I define a tuple as 4 comma 8 comma a comma complex 3 j. So let us say I have defined this tuple and I want to check whether 4 is in A. So if we do that, we get the true because 4 is available in this particular tuple. So if we want to check whether 8 is there or not, so 8 not in A. So it gives false because 8 is available in this particular tuple. So if we want to let us say multiply this tuple n times, which is equal to the adding the tuple itself n times. So let us say I want to multiply this tuple by 2, then the values are repeated, we can see that. And if we want to add twice, so we can see that a plus a is equal to a into 2. So it gives true because either we do addition the tuple with itself or multiplied by 2, it is going to be same. So as it happens in our numerics. So similarly, we can also look at the ith element in our tuple. So let us say our tuple is A and we want to check what is the second element. So it is A. So in Python, the index starts with 0. So first element will be 0, second will be 1, and this third will be 2. So second index returns us A, which actually in number is third, but in index Python index starts with 0, so it will be a second index. So in a manner, there are more operations that you can try on your own are available in case of tuples. Now, range is also one of the important commonly used sequence in Python, which is essentially used for iterations in for loop. So like tuple, it is also an immutable sequence. So I will see how it is used in a for loop in a bit. Uh, but it's an immutable sequence. So if once it's defined, it cannot be changed. Now, range is basically defined by start. After writing range and inside parenthesis, we defined a start, stop, and step, which iterates from start and in between values. These in between values are defined as start plus step multiplied by I, where I is the number of iterations. So, and it ends with a value that is less than the stop. So, after number of iterations, when the value is going to be get greater than the stop, it basically stops at the value which is just lesser than the value of stop. But this is true if the step is greater than 0. If the step is less than 0, it stops where where the iterated value is greater than stop. But more important point to remember is the iteration number. It should be an integer and it should be greater than or equal to 0. So we'll take an example here. If we want to calculate the range 1 comma 10 comma 2, so it will take values So sorry, it here it will be 2 comma 10 comma 2. So it will produce values as, sorry, 0 comma 10 comma 2. So it will produce, it will start with a start value 0, and then second value will be start plus step, which is 2, multiplied by iteration, which is first iteration. So it will return us 2. For second iteration, it will be start, which is 0, plus step 2 multiplied by 2, it will return us 4, and so on. But if we do the fifth iteration, it will return us start, which is 0, plus step, which is 2, multiplied by 5, that will be 10. But range should stop the value less than stop, hence it should stop at 8, it should not go up to 10. uh, Another example, another example, if we want to calculate the range 2 minus 10 minus 2, where it starts at 2, it ends near minus 10 with a step of minus 2, it would produce values using the above formula: 2, 0, minus 2, minus 4, minus 6, and minus 8, which is greater than minus 10. So next sequence in the list is lists. So in the Python is lists. So basically lists in Python, they are defined in a file in a manner. So we'll look it into the interpreter. So if we want to define an empty list, so we are giving it a name, let's like this A here. So empty list will be defined as square brackets. So it will take a list which has no value in it. It is called empty list. Now, if we want to give some values to the list, it should be given as, let's say, 2, then T. So this T is a string. We need to be careful while defining a string. If we define a string inside without giving, without I mean, we define a string without any quotes, whether single quote or double quote. Like here we have used single quote and T in between. So let's say I want to define a f as a string, which I am assuming it's a string, and I put enter. It gives me that f is not defined, because f, when it's not inside a quotes, it will not be considered as a string, and Python would look for this, whether it's a defined as a variable name, either inbuilt or user defined. So we have not defined f as a user yet, and f is not an inbuilt function. So that is why it throws an error that it does not know what it is. So we need to be very careful while defining these kind of I mean variable inside the list. So if we want to define a variable, we need to first define it. We need to first define the variable, then we can use it as an element in the list if desired. So we now we would like to correct what we did. So we'll define as a, or we have already used a variable a, so we can use that here. So we can see it has taken the a, which is not inside the quote marks. So because it's a already defined variable. So if we look the value of list, so we can see that it takes an integer value, string value, and a whole tuple is inside, defined as an element inside the list. So it can also take mixed sequences Lists are mutable, so we can change the elements of list. We can add the elements, we can remove the elements, and we can do more operations which are additional to the operations in case of immutable sequences. So these are the common sequence operations that we have seen, but in addition to that, more operations are allowed in case of mutable sequences. So you can try these operations. The definition is already given in parallel. You can try those operations and learn how to play with lists in Python. Next commonly used sequence is a string. So a string basically text type data in Python is dealt by strings. So strings are represented in many manners. So we'll try to have a look. Let us say I want to define a string, let's call it a string A. So to define a string A, either we will define a string inside a single quote. So we'll start with a single quote, we'll type a few things, and we'll end with a single quote. So our string will be defined. Or we can let's define another string but inside the double quotes, and we'll use the same values in here, and we would love to look that whether they are same or different. So we have used the same values that as in string A. So when we put enter and we try to check whether string A is same as string B. So for comparison operator, we'll be using double equal to, and we check, it comes true. So either we can use single quoted string or double quoted string to define a string in Python. We can also use triple quoted string, but triple quoted strings can take the multiple lines in Python. So let us say I want to define a string with single quoted string uh, that takes multiple lines. So it will be like, and if I press enter to go to the next line, it will give us an error. So if we want to change the line, it will give us an error. So what we can do, we can use a triple quoted string, triple quotes. So now if we want to change a line, it allows us, we can change many lines, and then we can type, but we need to be careful. We should end the string with the same triple quotes, and we'll get our string. So basically single quoted and double quoted strings will not take multiple lines, whereas triple quoted string will take multiple lines. So strings are also immutable sequences. They can take a mixed element types, so we can give the numbers in between, or values, or anything in between, and anything that is written in between the quotes is dealt as a text. So Python does not interpret them as a integer or float or complex or other type of things. It considers them or renders them as a text. uh, so basically string exclusive operators, they are also given in the documentation of strings. So we can use them, and we can learn how to use a string and how to make logical instructions using the strings. So those are given here in the link. We can follow them and get our get some more idea about the strings. So this is basically all. These are the sufficient basics, and now we can jump in with practice to learn Python in details and its applications as well. Thank you.